Everyone, and welcome to series 4, where we're going to show you how to create a reusable dialog with graphical output. And this is pretty simple, so I'll go through this presentation pretty quickly. I'll give you a quick overview of a graphic command. We'll create a dialog for bar plots, so that we'll take you through creating a dialog for bar plots step by step. And then we talk about handling composite graphic commands. And when I talk about composite graphic commands, I'm talking about a command like plot. When you run a plot and then you run another command like AB line that draws a line through the graphic or on your graphics device in R, and we'll show you how to handle that as well. So quick overview of graphic commands. When I talk about graphic commands, I'm talking about commands like excuse me, histogram, bar plot, plot, scatter plot. And with graphic commands, you want to be able to increase the size of the graph that's displayed in the output to provide greater clarity, and I'll give you an example of this. And you also want to be able to support overlaying the graph by a line. So I talked about that when I talked about composite commands. I use that name interchangeably here in the recording. And for example, you do a plot of a data set or two variables within a data set, and then you draw a line or best fit line or whatever you may have on that graph. Let's jump on to the first part, which is designing a dialog for a graphic function. So I'll use the typical format that I've used in all the other videos, where there's a part A, a part A, which refers to designing the dialog, part B, which is designing the output, and part C, which is installing, and you'll see that most of the parts remain pretty much the same. So part 1, which is designing a dialog, as I said, is the same steps. You pick the graphic function in R, the custom function, or the custom function that you've developed in R, or any out-of-the-box function in R. You design the dialog and map the controls on the dialog to the R function. You configure the dialog, so it generates the R command with the parameters correctly substituted, and I'll go through this in detail. And then you configure rules so that users don't commit inadvertent errors. So users should not be able to select or click on the OK button unless a variable or one or more variables are selected for analysis. So step number 1, we will pick the bar plot function in the graphics package. And the bar plot function is a pretty sophisticated function with lots of parameters. For the object of this exercise, we'll be concerned with just 3 parameters. The first is obj, which is a vector or a matrix of values describing the bars that make up the plot, a label for the x-axis, a label for the y-axis. And here's the syntax below that will get generated. So you're creating a bar plot of the count or frequencies of the subjects belonging to each education level. Here, education level is the column name in the dataset 1, and you're basically plotting a bar plot of the frequencies of each subject belonging to each education level. Again, don't worry, it'll become clear as I go through the example. You have a label for the x-axis and a label for the y-axis. So let's go ahead and talk about designing the dialog. The dialog's pretty simple. It has a source variable list that lists all the variables in the source data set. You've got a destination list box to capture the variable for which a bar plot will be generated. In the syntax, we will generate a table of frequency counts for each level of the variable that is selected there. Again, it'll be more clearer. And we also use the variable that you've selected, or the name of the variable that you've selected is used for the x-axis label in that bar graph. Let's go ahead and launch the application, and let's quickly design this dialog. So I'm gonna do file new function with dialog. I will drag a source variable list. I'll give it a name of source. Let's move it a little lower. I will drag a destination variable list. Give it a name of destination 1. And if you need more details on the dialog editor, you want to cover dialog editor basics, look at series 1 and look at series 2. Series 2 has some more sophisticated dialogs. So I will click on a move button, so I can move a variable to the destination list. That's the destination list. I'll give it a name of move, input list source, and the target where you move things to is destination 1. Let me copy the dialog syntax. To start creating dialog syntax, what you typically want to do is just take the syntax of a command and paste it in. In this case, I've got the ready syntax, but as you'll see, it's pretty simple. The command syntax is bar plot. I run a table on the variable that's selected, and I use that same variable that's selected as the x-axis label. So pretty straightforward. Let me go and save this. Oh, I need to enter valid title. I'll call it bar plot. And I will save it to my cloud personal demo series 4. Let's call it bar plot. All right, let's go back to the dialog. So we've not only designed the dialog, but we've also mapped the controls in the dialog to the to the syntax. So there's only one control that we need to map to the syntax. That's the destination list, or the variable that's dragged and dropped to the destination list box. And there will only be one variable that we will allow you to drop into this destination. We will, for the purpose of this function, we'll just support running a bar graph on one factor variable, and we map it as I've shown below. Again, if you need more details, you know what, I can show this to you really quickly. Okay, so I will double click on this, and in this case I will double click on this. So I'm just showing you how you map the controls on your dialog to the syntax command that you will generate. Okay, so I'll save, and let's go back to the next step. And in the next step, we want to configure the dialog so it generates the R commands with the parameters correctly substituted. So that's the source variable list. We will use the default settings for the destination variable list. We also need to configure the destination variable list so only one variable can be dragged and dropped, and I'll show you how to do that in a minute. But we'll use the default substitution settings of no prefix and use a comma to separate the variables. And what you see is that the same variable in this destination list box is used to generate a table of frequency counts. And when it's used to generate a table of frequency counts, we want it the variable substituted in the format of dataset $variable name. On the other hand, when we use the same variable in this list box as the x-axis, we will take the default. Okay, and the default is just the name of the variable. Okay, so here you see the default is ed. Or a pre-weight group. Okay, in this case I've just got ed, but you get the point that to generate the table, the variable gets substituted in the format dataset1 $ed, and to generate the x-axis, the dataset gets substituted with just the variable name. So the key point I want to make is if you put the $prefix before the destination list box name, and here the destination list box name is destination 1, we will ensure that the default substitution settings are overridden and that the variable name is substituted in the format of dataset $variable name. So basically what you've got here is you've got the contents of the same list box being substituted in two different ways. Okay, and that's what the dollar does. The dollar allows you to override the dollar before the destination one, here where I have my mouse over, overrides the default settings, which is no prefix, use a comma, and to generate the X label I use the default, which is no prefix, use a comma. Okay, and the dollar here just overrides it and makes sure that that variable gets substituted in the appropriate format. Alright, so let's go take a look at what this looks like. As I said, I only want one variable to be available here, so I'll set a max of 1. I also want the substituent settings to be the default, so no prefix, use commas. So I bring it up. I'm not going to touch any of it because I want the substitution settings to be the same. But what I want to do is I want to go and put a dollar before here. And that will make sure that when I'm generating the syntax for this subquery or the table part, it gets substituted in the form of dataset $variable name, while in XLab it'll be the default. Okay, so that's it in a nutshell. And in step 4, I'll configure rules so that users don't commit inadvertent errors. So we need to disable the OK button if the control is empty, or allow only one factor variable to be dragged and dropped to be moved. Okay, so let's go ahead and do that. In fact, before we do that, let me introduce the can execute property. Again, I've covered this in, I believe, definitely series 2. But basically a can execute property is available on all controls except labels and move buttons, and the OK button on a dialog is enabled only when every control on that dialog has the can execute property set to true. If any control has can execute set to false, the OK is disabled. So the rule we need to set is if the destination variable list is empty, we will set can execute to false. If it contains a variable, we will set can execute to true. All right, so a couple of things. The first we want to do is make sure that I only have factor variables. So I will change the filter and I'll remove scale. Okay, I don't want date as well. And the other thing is, when this dialog comes up the first time, we want this destination list box to be empty. Or it's not we want it, it will be empty the first time the dialog comes up because you've not selected any variable for your analysis. So we'll set can execute to false. Okay, that will make sure that when the dialog comes up the first time, the OK button is disabled. And then we'll set a rule to make can execute true when there is one item. So this is the target is the destination variable list box, and when item count, that means there's more than one item. Oops, let me back up a little bit. I'm sorry. So the condition needs to be done a little differently. What we want to do is set the rule so when items count, okay, let me back up a bit. All right. So what we're going to do now is we're going to set a rule so that when there is one or more item in this destination variable list box, we will make can execute to true. Okay, right now when you come in the first time, can execute is set to false. That is because this list box will be empty when this dialog is brought up in the application the first time. You've not selected a variable for analysis. So what we want to do is, as soon as you've selected a variable for analysis, we will set a rule that is triggered off item count, and when item count is greater than 1, in this case item count is 2 because I've just got 2 variables there. Okay, but at the end there'll only be 1, and we'll set it up correctly in a minute. So what we're going to do now is we're going to say if item count is greater than 0, we will set can execute to true, and can execute of the same destination variable okay, and at the same time, if it is equal to 0, we will set can execute false. So item count just tells you at runtime how many items are in your destination variable list. So if it is equal to 0, we will set control name, that's destination 1. Oh, sorry, false. Okay, if it's equal to 0, we want can execute set to false, not true. Okay, and that should pretty much cover it. Let's save it. Now let's take a look. Let's try it. We'll preview it. Initially, the destination variable list is empty, and can execute by default is set to false, as I initially set it to false. That will make sure the OK button is disabled. Remember, the OK button is only enabled when every can execute property of every property on this control, of every control on this dialog is set to true. In this case, it's set to true. In this case, it's set to true. In the source variable list, can execute is set to true. In the move button, it's not really relevant. But in the destination, I've told you I've set can execute to false. Now I will add one variable. You will see can execute will become true because of my rule, and the OK button is enabled. I will remove that variable list control. Item count becomes 0. Can execute of this control, my mouse is over, that's a destination list control, gets set to false, and the OK button is disabled. Okay, again, I'm just showing you how the rule that I've just set works. And I'm gonna, when I drag a variable, item count is greater than 0, can execute is set to true. When I remove a variable, item count becomes 0, can execute is set to false, and the OK button is disabled. Alright, so again, I've discussed this in even more detail in video 1, video 2s. If you're still confused, just hit us at our support email address, and we'll have someone contact you and walk you through this. It's really quite simple. I think that is pretty much it. Let me go back to the presentation and check. Yeah. So we've created the dialog. Let us go ahead and install it in the application. Okay, let's go to Tools, Dialog Installer, and I will overwrite my test dialog here. Yes, and I will pick up the dialog we just created, which I believe we put to the iCloud directory. Yep, that's the bar plot. Okay, we will restart the application. Remember, once you install a dialog, you need to restart it, and we should be good to go. Pardon it taking a long time. This will not happen when you execute it. I've got some applications running in the background. I'm testing some database work, so I'll show you. You won't see this in the final build, but let us open up a data set now. Yep, we can open this one, I think. Okay, and I will run the command we just created. Okay, and there you see the plot has been generated, and you see the syntax where the same variable that I've selected is substituted in the syntax in two different ways. One just as is, as a string, and one is with dataset dollar variable name. All right, so let's go back to the presentation and let's talk about designing the output. So the graph that is generated when the function is run is automatically saved to the output. You already saw that. You can right click on the graph and save it as a PNG. So I can right click, hit save as, and I have the ability to save it as a PNG. That's fairly straightforward. I won't save it. The syntax, as you saw, is fairly straightforward as well. Installing the dialog with graphic commands remains the same. In fact, I showed you, I just installed the dialog. You saw pretty much what I did. In this case, the bar plot is in the graphics package, and that package was automatically is automatically loaded by the BlueSky application. So I didn't have to do much. All I needed to go is go to Tools Dialog Editor and install the new command. I didn't have to create a new package, or I didn't have to install the package that contained my graphics command. And again, these slides have those details. You can take a look at it. I wanted to spend a quick 30 seconds talking about how we handle composite commands. So you may write a dialog for a plot command and then run an AB line or a lines command to plot a line through the graph. All you need to do with the BlueSky application is to put both the graphic command and the composite command that draws a line through the initial through the graph in double quotes. Okay, so when you're running it in the syntax editor or your I'll just show you. If you're running it through the syntax editor, go ahead and put it in brackets. So I'll show you it without the brackets, and I'll show you it with the brackets. So and let's do lines. Okay, so if you just run it as like that, that's not going to work. Okay, you'll get an error. You'll get the plot, but you won't get the line through the plot. However, if you just come in here and put it in brackets, it'll plot just beautifully. Okay, so that's pretty much all there is. Oh, one more thing. You may want to change the size of the graph. So in the output, you see here, you may want to, for instance, increase the size of the graph to make it clearer. So go into Options, Configuration Settings, Image, and in this case, I'll just change it to 600 by 600. Okay, and you'll see that I'll just have a bigger graph in my output. Fairly straightforward. Run the command. Okay, and there you see this is my new bar plot. This is the old bar plot, and the new bar plot is much bigger than the old bar plot because I increased the size of my graph. Okay, so I've talked about that. I've just shown you the dialog here. It's under Options, Configuration, Settings. And to summarize, we've created a reusable dialog with graphics output. It's very, very similar to a command that, for instance, creates tabular output or any R analytical command. Very, very similar process. I've given you all our dialogues are in the sample dialogues directory. The dialog name is bargraph.bsky. We didn't call it barplot. I can't remember why, but anyway, it's bargraph.bsky. And you go ahead and review all the videos. We've got a dialog. The series 1 is using dialog editor to create reusable dialogues and richly formatted output. Series 2 goes into a little more depth in terms of creating rules for your dialogues. Series 3, it shows you how to create a reusable dialog for a data manipulation command. We just talked about creating a reusable dialog with graphics output, and series 5 and 6 are available as well. So I'd like to thank you for your time, and email us at support@bskystatistics.com with any questions or comments. Thank you very much.